Never before has a man-made object come so close to the sun. The Parker Solar Probe will provide unique measurement data about our star. But for all the excitement about this project, people are moved by one question. Why doesn't the probe melt when it's near the sun? The Parker Solar Probe periodically stays in the hottest layer of the sun, and that is by no means the surface of the sun. It is hottest around the sun in what is called the corona. The journey to the sun, exploring our star, is of utmost importance to us Earthlings. Without the sun, there is no life on our planet. Our climate and seasons depend on solar radiation. The activities of the sun also constantly influence the magnetic field of our planet, and some people even claim that solar storms have similar confusing influences on the human psyche as the full moon. From a purely scientific side, astronomers and cosmologists would especially like to learn more about the hitherto mysterious processes on the surface of the sun and the corona. Corona means wreath. This thin glimmer around our sun can only be seen from Earth with special filters, or during a solar eclipse. The corona is a great mystery for scientists until today. After all, temperatures of up to 1 million degrees Celsius prevail in this layer, which is located several kilometers above the surface, while the temperatures on the surface of the sun are only about 6,000 degrees Celsius. The sun, like its corona, is not equally hot everywhere. On the surface of our star, constant mergers take place, things bubble up and forces swirl around. It is similar in the corona. Only there, the heat is in the form of the finest particle clouds. These clouds, or evaporations, are directly influenced by the activities on the surface of the sun. The particles that form the corona are created by the fiery processes on the sun, or are at least influenced by them. These interactions are not yet known exactly, and it's one of the tasks of the Parker Solar Probe to find out more about these connections. Behind the effect of the extreme heat formation in the environment of the sun must be physical forces and probably also chemical processes which we do not know of so far. Perhaps we could even benefit from the probe's findings with regard to our own energy industry. Just think that the electricity that you draw from a wall socket always comes about through the generation of heat. If we were also able to generate temperatures or heat using the same trick that the sun uses, we might be able to generate larger amounts of energy much more easily or multiply energy in a simple way and possibly in a more ecological way. In addition to studying the enormous heat generated in the corona, the probe is, of course, also measuring the famous solar storms. These are gigantic particle eruptions. The winds originate in violent eruptions on the surface. During these eruptions, plasma and particle streams are released, which initially waft around in the immediate vicinity of the sun. Eventually, the charges also enter the corona and are released from the sun's gravitational pull by a mechanism that is still largely unknown. Then, these particle streams drift away from the sun at extreme speeds and out into space. If these particle streams meet the magnetic field of the Earth, this is extremely shifted and stretched. Experts assume that such solar winds can override the complete earthly electricity if they reach a certain strength. Solar flares and winds have been intensively researched for not quite 100 years. This was enough to find certain rhythms in the eruptions and the winds. The sun is usually subject to an 11-year rhythm. Within this time, the eruptions occur in certain patterns. The winds were almost predictable for a certain time. Then, suddenly, the behavior of the sun changed. At first, the activity weakened in an unusual way. Scientists were already worried. But then, suddenly, the solar activity increased again. These events happened completely outside the cycles known so far. So far, on Earth, we cannot be sure that the sun shows extreme whims in its behavior from time to time. Since this could be dangerous for our increasingly technical world, it's of utmost importance that we learn more about the sun. A total loss of electricity would plunge the planet into indescribable chaos within hours. So, the Parker Solar Probe has an enormously important scientific mission in many ways. The Parker Solar Probe launched in August 2018. The Solar Probe is a joint project between NASA, ESA, and several other nations. To launch the probe, NASA took advantage of a window of time when the Sun and Earth were particularly close, and the probe's trajectory was ideal. Since probes cannot head straight for their destinations, but rather move along the gravitational fields of planets and ultimately also use their force for the onward flight. The Parker Solar Probe first made 7 laps around Venus before it could set course for the Sun. Of course, NASA also used these flybys of Venus maneuvers to gather a few new impressions of Venus itself. In April 2021, the time had come. The probe flew through the glowing hot corona of the Sun for the first time, and now you can find out how it did it. During its flight, the probe came within 6.1 million kilometers of the Sun's surface. Despite the 2,500 degrees Celsius outside, the sensitive measuring instruments inside the probe stayed at just over 30 degrees Celsius. International teams of scientists, engineers, and technicians spent nearly 10 years tinkering with this masterpiece. Key to the probe's success is a sophisticated thermal protection system that includes special materials, a heat shield, the probe's position, and a water-powered cooling system. The Hopkins Applied Physics Lab in Maryland, USA, was responsible for building the water cooling system. The thermal protection system has 2 layers of carbon fiber reinforced carbon, which retains its structural properties even at the highest heat. There is also carbon foam between these layers. There are such large air pockets in these fibers that hardly any heat is transferred. On the outside, the Parker Solar Probe is completely encased in white aluminum oxide. The color and material reflect light in an optimal way, so the outer covering reflects more heat than it absorbs. Between the carbon and the aluminum oxide is a layer of tungsten. This almost white and very dense heavy metal only boils at a heat of 5,900 degrees Celsius. Due to the separating layer of tungsten, the outer skin and the carbon layers inside the probe practically cannot react with each other. The heat stays outside, even under the extreme conditions in the Sun's corona. The position and trajectory of the probe are programmed to always keep the shield toward the surface of the Sun. To ensure that the Parker Solar Probe can still look directly at the Sun, cameras and measurement sensors have been placed so that they just barely peek out from behind the protective shields. The flight through the outer corona. Even on its next flights, the Parker Solar Probe will only pass through the outer layers of the corona, and only for a very limited time. In these outer layers, the amount of hot particles with which the probe comes into contact is very small. The heat transfer will, therefore, remain at a tolerable minimum. You can roughly compare the flight of the probe through the extreme temperatures to reaching into a hot oven. As long as you don't touch the metals or any heated food in the oven, you won't get burned if your hand stays in the oven for only a short time. The Parker Solar Probe's fly-through times are specifically designed to correspond to a short dwell time in the oven. Although the probe was perfectly equipped, the scientists and engineers on the first pass held their breath. When the Parker Probe remained fully functional on April 28, 2021, even at temperatures approaching 3,000 degrees Celsius, there was great joy among NASA and all the other facilities involved. At a speed of 586,000 kilometers per hour, the probe briefly raced through the corona, took initial measurements, filmed a stream of particles, and departed after only a few hours. During the times when the probe is far from the Sun, it periodically approaches Venus or Mercury again. Of course, the scientists would like to use these times to explore these 2 planets closest to the Sun a little more closely. Also, during these periods, the probe again uses the gravitational forces of Venus to accelerate and set a course toward the Sun with renewed vigor. The next approach to our star will not occur until 2024. Scientists will need a fair amount of patience for this exceptional mission, but it will be worth the wait. The first results were already unique for researchers, and the evaluation of the measured data will take several months. The probe will probably come closest to the Sun on December 24, 2024, of all days. For the researchers, it will then truly be Christmas. They can look forward to the unique measurement data and images as a gift. Currently, a total of 5 approaches are planned, the last of which will take place in July 2025. Of course, everyone on Earth hopes that the probe's design will survive all flithroughs well. Nevertheless, researchers and technicians do not expect the probe to be functional for longer than the summer of 2025. If the Parker Probe is still functional at the time of its scheduled mission, the mission can be extended at any time. The 5 flybys are expected to be quite enough to provide solar researchers with exactly the data they need to make important discoveries about our star. Thanks to the data, we will know for the first time what is really happening on the surface of the seething star, what solar winds look like around the sun, and of course, what processes contribute to the sun emitting its radiation in specific cycles. The probe was named after the U.S. scientist Eugene Parker. It was he who coined the term solar wind, and Parker is still considered a pioneer in the field of solar exploration. Here at Digital Discoveries, we'll be sure to keep you up to date, and we look forward to sharing the most important solar exploration news with you soon. Now you tell us, what do you think about the Parker probe's unique design? Do you find it fascinating what technology makes possible, or do you take it for granted? We welcome your input and personal opinion on solar exploration and the Parker probe. Remember to mention your subscription in the comment if you have one, and to like the video. We're glad you joined us today, and we'll see you next time.